that we might still have on stuff, whether they're from the review or homeworks or whatever. Then we'll talk about the test format, and then we'll start Chapter 5 stuff. Sound good? Okay. Grace, we'll start with you.
Could you do question 2?
Sure. All right, worksheet 7, question 2. So we got basically 3 turns going on, right? You agree with that? We do this bearing for this far, then we do this bearing for that far, and then we do this bearing for that far. So I'm just going to think of this as 3 legs. Like the first leg, there's our bearing. So our standard position angle is just going to be 90 minus 38. So that would be 52. And the distance is just the distance. I do the second leg as a separate piece. So bearings 311. So it's over there. So there's my standard position angle.
Wait, so why do you go clockwise?
So the bearing is defined going from north clockwise.
Okay.
The standard position starts from the positive x-axis counterclockwise. So to do sine, cosine, or tangent, we need to translate our bearings into standard position angles. So I draw the bearing first, and then from that picture, I'm going to figure out what the standard position angle is. So my bearing of 311 would have been 90, 90, 90 is 270. And then 41 more for here. My standard position angle would be 90 and then 49 for this quadrant. So 90 plus 49 is 139. And then the distance is just the distance. Is that okay so far, Grace?
Yeah.
Okay. Again, feel absolutely interrupt if things you're not like getting enough from it, or there's still some piece you're fuzzy about, or any of that kind of stuff, okay? It's the point of doing this. Bearing of 128 is like here. So my standard position is here. So 90, 90, 90, and then 52.
How are you getting like?
Oh, sure. So the bearing was 90 to here, and then 38 more to get to 128 total, right?
Okay.
And 52 and 38 are just complements.
Okay.
So using the 38 is how I got the 52. I just didn't write down the 38 first because I did in my head.
So they also have to.
Each quadrant is 90 degrees, right?
Yeah. Okay.
So like you figure out how much of in the quadrant your bearing took, and then the other part of it's going to be the complement to it. And then your standard position, because it's going the opposite direction, we use the complement piece. Does that feel okay? Okay. Again, if I buzz through something too quick, or you're like you still have questions about stuff or whatever, you're doing the right thing and hollering out, like keeping after it. That feel okay?
Yeah.
Okay.
So like the distance is always given to us.
I'm sorry, what?
So the distance is always like given to us.
Or some way to find the distance, right? If it was like a speed for a certain amount of time, or you just have to multiply the two numbers together to get the distances. But yeah, I mean, it's not something you'd have to like really figure out algebraically or geometrically. It's going to be basically like either given to you or like arithmetic given it to you. You know. Marco?
So did you just get the 322 by like adding them all?
Yeah, so I did 9, oops. We did 90 plus 90 plus 90 plus 52.
Yeah, okay.
Okay. So our final position then is just going to be the sum of the x components for each of those 3 legs, and then the sum of the y components for each of those 3 legs. So I'll go to my calculator. I need to make sure I'm in degree mode because obviously all these angles are measured in degrees. So my x1 is going to be the distance times cosine of my standard position angle. My x2 is going to be the distance times the cosine of that standard position angle. And my x3 is going to be the distance times the cosine of that standard position angle. So about 550. And then to get the y's, I'm going to do the same thing, but instead of using sine, I'm going to use, or instead of using cosine, I'm going to use sine. So 4.6 times sine 52, 6.7 times sine 139, and then 9.8 times sine 322. That gives me 1.99. Is that so far so good? So my final distance then is just going to be like the Pythagorean theorem on those values. So 5.85-ish. You good with that, Grace? Okay. And then to do the bearing, I'm going to plot that point. So I go 5.5 over and basically 2 up. So something like that. You good there?
So like you're ending the line at 5 and then 2 up?
So I'm just plotting the point, 5.5 comma 1.99. And then I'm drawing from the origin to that point, right? So this is my bearing. So that's 0 degrees, that's 90 degrees for a bearing. This piece is going to be my alpha. So my bearing should be 90 minus alpha. Because the last piece that we crossed was the vertical. Is that cool? Yeah. Okay, just like we did before. And the alpha is always going to be the tan inverse of absolute value y final divided by x final. Now I'm going to drop, or I'm not going to worry about the absolute values because everything is, the x's and y's are positive in this case, so I'm just going to save myself the buttons. So I'm going to have 1.99 divided by 5.5. So when I do 90, what did I do here? Did I forget the 90 minus? Yeah. It's like, that can't be right. 90 minus the tan inverse of that, I get 70.13 degrees. Is that okay?
Yeah.
Sure. Well, it asks for how far and what is his bearing. So the how far was the distance, and the bearing is the bearing. So I have two answers because the question asks for two things. Alyssa.
For that first leg, did you only do it like to 90? You didn't add the other three quadrants?
Well, it said it was, the first leg was 38-degree bearing.
Oh, sorry.
So like, this is 38, and this is 52.
So you wouldn't add the other three like you did for the two legs?
Well, look at the standard position angle is the blue, right? So we're just going 52 degrees to the terminal side. Is that, as opposed to this one where I'm going 90 degrees and then 49 degrees to the terminal? Does that, I don't know if I'm answering your question.
Sure, yeah.
Oh, Alyssa. I want to do a good job. If I'm not,
No, it's not you. It's just
okay.
well,
We can talk it out if you need to talk it out more.
it's all good.
Okay.
And
I
then-
don't want to frustrate you. Is not my
Okay.
goal.
And then
Okay.
for the review packet,
Yeah.
can you just explain what you did for page 3F?
Sure. Let me grab the review here. Grace, you're happy with what we did there, though?
Yeah,
Is-
so like, is that on the test?
We'll talk about the test format, but the short answer is you'd have one such question kind of like that I'll break down into parts to make it a little bit more clear as what I'm looking for. And it'll be a little less dependent on like, if I got messed up this part, is it going to mess up the whole thing? Because I'll be able to see a little bit easier where the mistakes are. Okay, so Alyssa, you're on page 3, you said?
Yep.
And letter F. Okay. Okay. So this is a pure calculator question. The reason I know it's a pure calculator question is when I look inside, 98 degrees is not a unit circle angle measure, or negative 98 degrees. Although 98 degrees is a pretty cool 90s boy band, or 2000s. No, that's not a funny joke for anybody. Okay, I get it. I'm old. What's up? Oh, I made a 98 degrees boy band joke. Yeah, that was Nick Lachey's band. Do you know Nick Lachey?
Yeah.
He's still kind of reality TV relevant.
I know.
Okay. You're a liar. Anyways, so Alyssa, are you still doing okay with my observation there?
Yes.
Okay, so I'm just going to do this as 2 stages. So inside my calculator, I'm going to do the sine of negative 98 degrees. To do that, I need to be in degree mode. So sine negative 98. So I get negative 0.99 and change. And then if I want to do sine inverse of that, it's going to give me an angle measure. The directions ask to use radians if I'm giving an angle measure. So I'm going to have to change my calculator mode back to radian mode now. And I'm going to do sine inverse of that answer. And I'm going to get negative 1.43. So on all the problems on this page, you're really just kind of working from the inside out. So I think on all the other, well, no, not on A and D are both the insides you'd be using your calculator to do. But on B, C, and E, you'd be using the unit circle to do the inside parts and the outside parts, really, because you should recognize these three as all unit circle angles. 3 pi over 4, 5 pi over 4, and negative pi over 3 are all unit circle angles. As opposed to 0.89 is not a unit circle value, right? Like that's not a coordinate anywhere. Neither is negative 0.34, and negative 98 degrees isn't a unit circle angle. So those are all ones that scream calculator to me. And those are ones that all are total calculator problems. There's nothing really to write down per se. Is that helpful?
Yeah.
Okay. Raylan?
Maybe I'm using the unit circle, like
B, you say?
yeah.
Certainly. Okay, so again, we're going to start with the inside. So I'm going to go to the unit circle, find 3 pi over 4, and then I know tangent is y over x. So unit circle, 3 pi over 4, y divided by x is going to be negative 1. You good with that? Okay. So now we have to be careful because I know the range for tangent is negative pi over 2 to or for arctangent, excuse me, is negative pi over 2 to positive pi over 2, which means that we're talking about quadrants 2 and 4. So the place where tangent is negative is here in quadrant 4, right? Using all silly turtles crawl. So the angle we're looking for is this one. So I'm going to go to my unit circle, and I'm going to look for the place in quadrant 4 where y divided by x gives me negative 1, or really just the x and y are opposite signs. I really should just say opposite. So if I go down to quadrant 4, that's the place where x and y are opposite, right? One is positive root 2 over 2, the other is negative root 2 over 2. See that? So the angle measure that we're interested in is 7 pi over 4. The problem is that 7 pi over 4 is this angle. So what do we need to do to convert that blue one into the red one? Good. What are we going to subtract? 2 pi? Yes, very good. So when you do that, you get negative pi over 4.
How do you know that I'm not using quadrant 1 again?
So if I do all silly turtles crawl, I'm looking for where tangent is negative. So in A, all the sine, cosine, and tangent are positive, so it can't be in 1. In 4, only cosine is positive, so sine and tangent are negative.
What about in quadrant 2?
Well, it can't be in quadrant 2 because the range for tangent inverse is from negative pi over 2 to positive pi over 2, so I'm only considering things in quadrants 4 and 1.
Wait, how do you know? Is that standard?
That is, if you are not given an interval to solve for, that is the fundamental domain for tangent inverse.
Okay.
So, or I should say fundamental range for tangent inverse. So, for sine inverse, cosine inverse, and tangent inverse, the domain is and then the ranges are this, and this is something that you certainly want to be familiar with because you need it to do problems like certainly these ones some of these problems A through F, but you absolutely have to have it to do these problems like question 1 here on page 1. Because the big takeaway here is you got to make sure that you're giving an angle measure that can actually come out of cosine inverse, sine inverse, tan inverse. And the takeaway here, the two where you have to be really careful about are the sine inverse and tan inverse of a negative value. Those ones are going to be located in quadrant 4. Those are the ones you'll have to subtract 2 pi from off the unit circle. Tangent you don't have to, or cosine you don't have to worry about because the range is 0 to pi. So the number you pull from the unit circle will just be the angle measure. But sine and tangent you have to be careful about. Is that helpful? Medium helpful? Highly helpful? Margo.
I have 2 questions. So first, on the test, are you gonna tell us when we need to be in degree and radian mode?
Well, the directions will tell you, or that it'll be obvious from the context of the question, like if it's a story problem with degrees in it.
Okay, perfect. And then also, can you do another one for worksheet 7?
Yeah, which one? I mean.
Can we do the last one? Like the very, I guess.
Okay. Yeah, this one is poor. I worded rather poorly, but we'll square this one out here for us. So we're planning to get to this place, right? So that should be our final destination. So I'm going to use like a B sub F for the bearing. And to get there, well, we have a wind that has some bearing that's blowing at some speed. We also have some ocean current that's flowing at some bearing at some speed. And then we're going to have our ship, and we're asked like, hey, what bearing do we need to set sail on? And we're told that the fastest this boat can go is 22. So I'm going to put the 22 over here. That's the part that I think is really not well worded as to where that 22 is supposed to go. Right, so you set sail and you want to end up at some place, but you have to worry about accounting for the wind and the current. Like, okay, so we need to wind and current, like, can I get here? You know, like where should I actually aim my boat at to end up where I want it to go when I got all this other stuff to contend with? Does that make sense? So what we can say then from this is that initial is going to be the final minus the current minus the wind. You buy that from kind of the read on this story problem? Okay. So this is kind of my setup. So I'm going to resolve my or break that final up into components, and then the current up into components, and the wind up into components, and then subtract them as I've described there. So my final, I'm going to have a bearing of 114. So that's 90 and 24. So the standard position angle for that is 90, 90, 90. And then 66. So that's going to be 336. And we'll do the wind. So the bearing on that is 51. So that part is 39. And we have the current. The bearing on the current is 281. So we're up over here somewhere. 90, 90, 90, and then 11. So that's going to be 90 and then 79. Margot, so far so good?
Yeah.
Okay. I'll resolve these into components then. So just speed times cosine of my standard position.
Wait, I actually have more questions. Sorry.
Yeah, go ahead.
Where did you get the 13 from?
The problem?
Oh, but like,
It says the ocean current at 13 knots at a bearing of 281.
okay, my bad.
No problem. Again, like, ask if you're not sure.
Okay.
I mean, sometimes it's like a simple answer where it's like, you should have known that, but like, it's okay. You can ask. Not a problem. Don't be embarrassed. Or be embarrassed. I don't want to tell you what to do. If you want to be embarrassed, you can be embarrassed. You know, I've asked a lot of dumb questions in my day, right? So, how do you get smarter? By eliminating your, the things that are dumb. You know what I mean? Like, it's part of learning, right? If we all knew the right answers to everything, there's not a lot of point in what we're doing here. You guys could all just be teaching the class if you already knew what to do for everything. So to find the initial position, then, we're going to take the x parts and subtract them, and take the y parts and subtract them, just as we described earlier, right?
Yeah.
Okay, so this is all calculator time. Make sure we're in degree mode. So you can see already that this is a potentially nightmare test of switching your modes back and forth, right?
Yeah, so like, maybe
Well,
if you
if you show me the right stuff and you have the wrong mode, but like a lot of these are things that realistically, if you get like bat crap crazy answers, you should know to go back and be like, what's the most likely mistake I'm making here? Is mode. So there's my x component for my initial position. Oops. And there's the y component. Did I screw that up? Let me just look. That doesn't seem like the right number. It's not. Oh my goodness, Mr. Kulik. I know, right? I'm sad for myself. Look at what I did.
I'm simple.
Look at what I did. I put plus signs instead of minus signs. That is such a Mr. Kulik mistake. It does, right? If we were all perfect, well, it'd be boring, right? Life would be boring if nobody ever made any mistakes. So 2586 and 1709. What's up?
You're being so inspirational today.
I mean, yeah. I mean, you guys seem like you needed a little bit of a pick-me-up, so let's
That is so true. I'm not feeling confident in this.
let's just be we'll be real, right? Raylan.
Okay, wait, this might be a dumb question, but how do you know there's a chat the initial here, but like we added, like on number 2?
Sure. So it's from I'm getting this from the wording in the story problem. So here we're asked like, okay, if I want to end up at this spot and I have to account for like this wind and current, like where should I really be aiming at? So it's like, okay, I need to set off in this direction at this speed because all this other stuff is going to hit me and move me somewhere new. So it hits me and moves me to the place where I actually want to end up at. So here I'm seeing that like what I know is the final, what I want to find out is the start. In the previous problem, it's like, okay, we start off and we do this and we do this and we do this. Where do I end up at? If we are asking about the end, everything is going to be added. If you're asking about the start, we're going to have to be subtracting. Is that?
Yeah, that's
Okay. Just as a like word decoding, just if we talk about like the world, right? Like if I know what the end looks like, I'm going to have to subtract off the things that happen to get to the start. You know what I mean?
yeah.
And that's kind of what's going on. It's the kind of the simplest explanation. Okay, so there's our initial position. So if I plot that, let's just find this. We don't care about the speed. I just asked for the bearing in this problem. So if I plot that, I'm 25 over, 17 down, so I'm over here somewhere, right? So there's my bearing. This spot is my alpha. Since the last axis I passed was horizontal, I should be adding my alpha. And alpha is the tan inverse of the absolute value by f divided, I guess in this case it's i's, right? yi divided by xi. So 90 plus tan inverse, and I'm going to pull the absolute value command because I actually do have like a negative number here. So rather than monkeying around too much with it, I'll just use the absolute value command on my calculator. So I get 123.46 degrees. And this question asked just for the bearing. It didn't ask for the speed. So that's why I didn't calculate the speed. You could if you wanted to. But I don't really care. Let's work smart, not hard, right? Margot, did that feel like what you're looking for?
Yeah, thank you.
Grace, you happy with what we did there?
Yeah,
Okay, this felt like a collaborative question between you two.
it was.
So,
Really worked together.
yeah. Wonder Twins activate. That's an old TV reference that's older than I am. So
yeah, that one.
thanks, Grace. All right. Who's next? Alyssa.
So for the review packet on that first section, are you also using so in order to know which quadrant it is in, do you use like the domain and range thing that you gave us?
Yes. Yes, absolutely. because most of these, there's at least, there's usually at least two locations where this could be happening between 0 and 360, or 0 and 2 pi, I guess, since it's asking for radian answers. So to figure out which one of those locations you're looking for, you're going to be using the range from those inverses that we had just mentioned a moment ago.
Can you do B?
Sure. So we're looking at arctan. I know the range for arctan is negative pi over 2 to positive pi over 2. So we're looking at quadrants 1 and 4. Tangent is negative only in between 1 and 4 and only in quadrant 4. So we're looking at this angle. Cool with that?
Yep.
Okay. So I can, from the unit circle, look up this angle, because the unit circle has only the standard position ones that are positive. It doesn't have negative angle measures on there, but no biggie. So I'm going to find the spot on the unit circle. Tangent is y over x. So I'm going to look for the place where y over x is negative 1. Or really, x and y are opposites. So if I go to my unit circle and look in quadrant 4, the place where x and y are opposite is here. So the angle measure I want is 7 pi over 4. Okay with that?
Yeah.
But that's not my answer, because that's the blue angle that we've drawn. To get to the red angle, I'm going to subtract 2 pi, which gives me negative pi over 4. And in general here, when there's places where we're going to have to subtract this negative pi over 4, or I'm sorry, negative 2 pi. So any place where I see tangent and a negative, I know I'm going to have to be doing that, as well as any place I see sine and a negative. I guess there's no sine and negative ones on here. But the rest of them, I'm not going to have to worry about the subtracting the 2 pi. Because the rest of them are either going to be in quadrant 1 or involving cosine, which is fine, because cosine doesn't have, the range for cosine inverse doesn't have any negative angle measures in it, so I don't have to worry about that. You just read it right from the unit circle.
Is arc, I thought arctan was what, tan inverse?
Yes.
Is that not x over y?
So, okay, so tan inverse doesn't mean the reciprocal of tangent. So tan inverse is a separate function.
Oh, okay.
So like cotangent is the reciprocal of tangent, which is not the same as tan inverse.
Oh.
So that's an important thing, right?
Yep.
For both sine, cosine, tangent, cotangent, cosecant, cotangent, what you're doing is you're taking an angle to a ratio of side lengths or a position on the unit circle. For the inverse functions, you're taking that ratio or that position on the unit circle and sending it back to an angle. So the inverses are undoing what the regular function did. The reciprocal is just another version of that, of a mapping from an angle measure to a position on the unit circle or a ratio of side lengths or something, depending on which definition of sine, cosine, tangent we're talking about, since we have 3 of them. Does that?
Yep.
Okay. And that's an important distinction, right? That's easy to kind of get lost, because when we say inverse, sometimes we're talking about a reciprocal, right? Like if you say what's the inverse of 1/2, you really mean its reciprocal too. But if you're talking about an inverse of a function, you're not talking about its reciprocal, most of the time anyways. I mean, I guess there could be some case where that is what you're talking about, but it's in general, it's not what you're talking about. Does that?
Yeah.
I think that, and that's an important distinction that sometimes gets lost, right? We skate past that pretty quick, and that vocabulary is important, that we all understand what's going on. Great. What else do you guys want to talk about? Should we do the test format? Okay. So in the content library, I made a tab here that just has test questions for chapter 4. So this is the normal test format that I would give you guys. So we have 2 questions where we're just using the calculator to find an inverse, which is literally like just typing the stuff into your calculator and writing it down. 2 questions where we use the unit circle to find the exact value for the inverse, similar to those questions we were just talking about, Alyssa. 2 questions where we use the unit circle to find the exact value of a nested inverse trig and trig function. So what do I mean by that? I'm talking about something like these problems in question 4, where you have like sine and then cosine inverse inside of it, right? Where you have 2 of these things nested inside of each other. Is that okay? You guys clear on what we mean there? Okay.
Wait, what question was that?
Yeah, these ones, we talked about a couple of these when we went through the review. Is that cool?
Yeah.
Okay. I hope this is helpful too, that what we're doing, right? One question where we want to find the algebraic expression for one of these nested trig and inverse trig function problems. So this is like worksheet 4, was like a whole worksheet on this stuff, right? So problems like these from worksheet 4, you'll have one of those. One question where we're going to use our calculator to find the value of an inverse over a specific interval. So that was like worksheet 2 problems. 2 story problem questions. You better believe one of them is going to involve one of those weird systems that you have to solve with the tangents.
Like,
Or like
worksheet 7?
these would have been like the worksheet 3 questions.
Oh.
So you remember like on this last one on worksheet 3, where you have to like, yeah, or like this one on worksheet 3 where you have like a system to solve where there's 2 triangles that you're missing 2 parts of each of them.
That is so mean.
You better believe there's gonna, well, it would be mean if I didn't tell you, right? The fact that I'm telling you makes it like slightly less mean.
No.
Still maybe a little mean,
No.
but like way less mean than just like, oh, surprise,
Yeah, I should know this.
right? At least if you're ready for it, it's like, okay, I make sure to practice that a couple of times. And then one question that's like one of these navigation story problems, like on worksheet 7. It'll be like one of the simple versions of it, where you just have like adding things.
Where do you find the first 2?
You're talking about these 2 questions?
And then the other one.
So this is just like question 1 off the review. So just like this stuff. The other one is just like legit, you just type it in your calculator, like sine inverse of, negative 1.2 is, in radian mode probably would be the context. Oh, yeah, of course. I meant 0.12, typoed. It's like, boom, there's your answer. It's just like you just write it down, whatever it is. So just like the smallest part of, we do this all the time, right? Like we do the sine inverse on the calculator for all these problems. It's just like making sure you can get your calculator in the right mode and get this in there. You know what I mean? It's not really like, it's such a simple thing. It's just a couple of like filler questions to make sure we end with the right amount of points to make it not, the math not super inconvenient for me. Just like a couple of gimme softballs at the end or at the beginning. Is that okay? Of course. Do we have a decent picture about what it is that we have? Oh, Alyssa.
And then like on the review, there's like times where on the page where you like have to write out like which quadrant it is in. It's on page 2, I guess.
Okay.
Would you would be like 0 minus alpha plus the 4 pi. When would you need to do that necessarily?
Okay.
Like,
So the answer is, depending on how you're doing the problem, never.
Okay.
So the way that I've done the problem, where I've shown you guys, I've always just kind of accounted for the interval when we've like drawn them. So like I'll draw this, I'll be like 0 pi over 2 pi, 3 pi over 2, 2 pi, blah, 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 3 pi, 3 pi over 2, or 3.5 pi, 4 pi, and then like 4.5 pi. So using this, and sine is negative here, so we're doing that. This is my alpha. So I would just do this as 4 pi minus alpha,
Okay.
and then that's it.
Yeah.
Sometimes in the past we had like gone and shrunk this down and made it coterminal, and then like by subtracting multiples of 2 pi from the ends to get a different interval that we don't have to go around multiple times or whatever.
Yeah.
And then you have to add that back at the end. I find it, in my experience of doing it, that the way that I'm currently showing you with just counting around and drawing the picture and then using the picture to generate our equation and not having to fiddle around with all that stuff goes a little bit better for a lot of students, where you can just kind of look at the picture and it's not like you have a little bit more foundation from it. And you're not questioning about like, hey, how much should I be subtracting or whatever, like just, that's okay?
Yep.
Josie, you had your hand up also.
Yeah, can you do number 4 on worksheet 4?
Yeah. Sure. Oh. Okay. So these problems on worksheet 4, we're going to work from the inside out. Yes, Justin?
Can I go to the bathroom?
Yes, of course. So I'm going to use this to draw a triangle. And just not any triangle, but a right triangle. And I'm going to label one of the acute angles as my theta. So the inside part says that theta is cotangent inverse of x, right? That's equivalent to saying cotangent of theta is equal to x. Inside of a right triangle, cotangent is adjacent divided by opposite. So in this triangle, my adjacent side should be x, and my opposite side should be 1. Cool with that? I can find the third side using the Pythagorean theorem. So I know that a squared plus b squared should equal c squared. So my c should be 1 plus x, or the square root of 1 plus x squared. And I know that that square root has to be positive because we're talking about the side lengths in our triangle, so I can't have a negative side length. So far, so good? Okay. So now that we've done this, we've essentially broken this down to just secant of theta now. So using that right triangle that we have, theta is hypotenuse divided by adjacent. So we have 1 plus, or square root 1 plus x squared over x. And I'm done. Yep. So again, the goal is to write an algebraic expression to describe this. That's what we've done. So it's going to have x's in it. That's okay. There's nothing to solve. And the whole idea is we're going to use the inside, the inverse part to draw a right triangle. And once we've figured out the side lengths in terms of x or y or whatever the variables are, we're going to then evaluate the outside using the right triangle that we built. Just using our SOHCAHTOA definitions.
Thank you.
Yeah, of course. Grace.
So, how would you feel if you got just to remember, like,
and
tangent, like,
and also like Thanksgiving's coming up. It'd be like a little. I'm so thankful for you guys.
I'm going to go with no. But I'm not mad that you're asking and that you've continued to ask every time. Right? Like, it's totally fine that you're doing this. And I'm doing it with a smile. It's totally fine. Okay? But I'm going to say no. Yeah, it's okay. Nobody's mad about it. I'm not mad about it. You can be mad about it, but just like do it later in your car where you can't hear, like, curse me out and everything you need to do to like to get okay with it. And that's fine. Like, I get it. That's fine. But we're gonna be nice to each other, right? Yeah, okay.
How about like a free like bonus point, like a little like extra credit?
Oh, you want an extra credit opportunity? I have one for you. So I had 3 of these calculators at the beginning of the year. I currently have 4. So somebody borrowed a calculator like this from me and never returned it. It has like these barcodes on it. If you find this calculator and return it to me, I'll for sure give you some extra credit. So it's a detective case, but it's out there somewhere. Somebody borrowed it from me and has not returned it. I don't know where it went to. But if you find it and return it to me, for sure, extra credit.
How about if you're a new calculator?
No, it's so much money. No way.
No, I actually have one.
Does it have the barcode on it?
No, I can make one though.
Alyssa,
use restroom.
of course.
Do you have your Christmas tree up yet?
No, not yet. We had to buy a new one. Because you remember all that rain this summer?
Yeah.
Our basement flooded and like lost a whole bunch, like almost all the stuff in our basement got bye-bye. Yeah, so it ruined the Christmas trees, which were in the basement. Yeah. But we got the replacement one. It came. So there's that.
Is it better?
Well, my wife picks all that stuff out. They're all kind of the same to me, honestly. But like, I think she likes it better than the one. She was already looking to replace the old one.
Oh, that is perfect timing.
So, I mean, other than like costing thousands and thousands of dollars for all the damages, but
Did you get from Costco?
no, she's fancy. She ordered it from some fancy. I don't know.
Yeah, Costco.
I don't know. Like I've never been to Costco. I'm gonna be honest.
What? Are you serious? We should take a field trip there. Yeah, we can like count.
Well, I don't really like to buy like a gallon of mayonnaise or like 200 light bulbs at a time.
That's
Like
the stereotype.
But like the free samples.
They're so good.
no, I take that back. I've been once. Mr. Butoric went with me so I could buy some light bulbs because I replaced the the can lighting with LCD or whatever. The light bulbs that don't ever really burn out. So that's all. I've been there once to buy light bulbs. I take that back. I went once.
They have good pizza. They do. Oh gosh, the pizza's
All right. Oh, gee whiz, we took a long time here, huh? It's, you know what? Like, it's okay. Here's what I am gonna say though. Like, after the test, I'm gonna ask you guys to do some stuff from chapter 5 to try to get caught back up here a little bit. So it's fine. Like, I want to, like, if you need time from me, I don't want to take that time, right? Like, this is important time. I acknowledge that, and I'm cool with it. Like, it's not a big deal. And I don't want this to feel like a punishment. We got to catch up a little bit because now we're like going on 2 days behind the B day, which again, like, not a big deal to get behind, but we got to, like, I can stall there a little bit, but like 2 days of stalling is kind of absurd. But we do need to do a little bit of catch up. Okay.
So is it gonna be like homework?
So, yeah, I would say that we need to. What's going to be the best way to do this? Because we have 20 minutes right now or something left in class. We should do a little bit of this, and then I'm going to leave you to kind of read and try the rest of it. So I'm going to give you like the speed version of the lecture so we can get to the examples, which I think are probably the more informative piece.
Got it.
Just to give you guys a heads up on kind of what's going on.